So thank you so much, sir, for your presence. In spite of your busy schedule, I'm sure you're gearing up for the HPI conclave to be held in Jaipur. I know that you've been traveling you had a very busy schedule. Gentlemen, HPI is now an active respondent to see that how 3D technology can be well understood and well promoted in the hospital setup and within the country. An association who've been championing the lead and taking the course forward in terms of patient satisfaction. And somewhere I think we could connect well in terms of understanding how this technology can also help patients to get the anatomical knowledge and understanding of the course. Doctors and surgeons are definitely going to be benefiting for sure. But I think this will also help in terms of building a transparency. What we also believe is every hospital getting into this kind of a module will also mean that we will also be able to measure patient satisfactory index, which is also an initiative that we've actually recently got a trademark. And it will be a great privilege to work with the HPI on this aspect to take the things forward, to also see that how this technology can get more penetration. And with more penetration will also mean, getting it more adaptable and with services and cost being also cheaper. So what we've done is there is one initiative is the 3D Graphy Lab. The other would be also the 3D Graphy technology partners as they keep registering with us. Our intention is to see that the best solution goes to the end user, the hospital, so that we are a consortium, and our intent is to see that the best solution is being offered to the end user, because at the end of the day the patient benefits in the course. So that's the kind of a larger intent, and we are now also the life partner member partner with the HPI. Thank you so much, sir, for your active support in terms of driving the course from there. And now also we will be joining HPI conclave in Jaipur on 10th and 11th to showcase the technology to almost 750 plus hospital heads and owners of the hospital to come and understand the potential of what this technology can do. Sir, over to you, sir. Thank you so much, sir. Over to you, sir. Thank you.
Thank you.
Also a formal announcement to be made, sir. I would want you to be making that formal announcement for us to take things forward. Thank you, sir.
No, you see, we have already, made you a partner in our HPI family, and in the first phase, we have decided to promote the 3D graphy in the 5,000 hospitals which have 100 bed and above, because this kind of technology can be utilized only when the hospital size is at least 100 bed and above. So this is what we are going to do, and I'm expecting your technology partner, as many as possible, to come over to Jaipur. We will welcome there, and we have already set up a stall for you there.
Great.
And we will be, introducing this subject and our partnership to our 700 plus delegates who will be attending from all over the country. So thank you very much for coming over and making sure that your technology partner will be joining and attending the conclave.
Thank you, sir. Thank you so much, sir. Thank you. And it's always a privilege to be a part of your consortium, sir, and also the association. Also because the association has taken the lead in terms of doing a lot of initiatives in this space, sir, in terms of hospital management, in terms of also accreditation and validation, and also with your key respondents being a part of the council of CDSCO and various other organizations, NABH also being an accrediting body. Sir, what do you think about the technology in terms of the scope, sir? I'm sure you've been actually mentioning that in various events that you had been actively participating, sir. But now that we are going to be working in Confluence, what do you see the scope and how is it actually going to help the patients? Though I did mention, but your thoughts, sir, please, sir.
No, you see, we have already identified the key areas like orthopedic and dental sciences. Right, and even in the cardiology, vascular, surgeons are actually finding it very useful. So, but only thing is, I think we need some effort to bring our hospitals on board.
Right.
So far, actually, we have not been able to do that. But with your joining us and making sure that we will conduct a number of webinars along with you at a different location. But the starting point is going to be that we have made you our lifetime partner, number one.
Right, sir.
Number two, we have provided you the biggest space in our annual conclave at Jaipur. and we will take it forward. I'm very sure about it that this technology is very, going to do a lot of good to our medical fraternity. So I welcome you once again, and thank you very much.
Thank you, sir. Thank you so much. Ladies and gentlemen, a very good afternoon, and we are just heading to evening, so it's almost evening. Thank you so much for your time, and sorry for the delay. We've actually been waiting for some of the key respondents to also join. Today, because the concept and the event is actually being focused on hospital, also setting up labs in hospitals. We have respondents join in from various hospitals. Thank you so much from Amrita Institute of Medical Sciences. We have respondents from Lifeline Hospital also joined. So thank you so much, gentlemen, for joining. And I'm sure during the course of the day, as we progress, there'll be a lot of insights that you will also get to know what is the concept of point of care. Because this is something which is very, very relevant and pertinent for all of us to know and understand that how hospital management can look at 3D technology and how it can actually translate and transcend the course of unique services and ensuring patient satisfaction at the end of the day. Because I think patient needs to be well informed, they need to be guided, and also need to be well abreast of the fact that how their anatomy and what is the procedure that they will need to get involved in to make things more convenient and easy. In this process, what we also understand is 3D technology constitutes of 3D imaging and 3D software and 3D printing, visualization, AR and VR is also one of the key aspects. So 3D Graphy as a company, we have taken this initiative working in confluence with AHPI, that's Association of Healthcare Providers of India, to promote this technology in all the hospitals in the country. And we are very privileged to have their accordance to be a part of this initiative. So today I have also got a panel of speakers and respondents who are experts in this domain from each of these areas of expertise in 3D technology, and also doctors and also technology service providers. In Dr. Vikas Jain, who is the Chief Technology Officer and also the Strategic Advisor with Orthotech 3D, Orthotech India Private Limited, now also Orthotech 3D as in 3D suit, a beautifully well set service center, ladies and gentlemen, in Valsad, to offer PSI and also even pre-operative surgical planning solutions to doctors from various specializations. But currently, the focus is on orthopedics. But yeah, as the organization progresses, they will also want to offer services in various other areas of expertise. I also have Mr. Sarup Chand, who is the director with Androtech Information Systems, who is also one of the key respondents in offering 3D technology solutions, also registered with us as franchisee technology partner, offering 3D solutions in various areas of expertise in software, in 3D printers, and also in terms of materials. So he comes with his expertise, and his organization has been well set in terms of offering these solutions. And we will also want his assistance to offer these solutions for the 3D Graphy labs that we will be setting up in hospitals. So thank you so much, Mr. Sarupchan, for your time. I also have Dr. Girish Rao. A very good afternoon, sir. Thank you so much for your time. Also, one of the key respondents, and I'm sure many of them would know him. He is the Secretary General with AOMSI, that is the Association of Oral Maxillofacial Surgeons of India. He's a maxillofacial surgeon by profession, and also a key respondent in also having understood the potential of 3D technology. And today he will share some of his insights on the subject, and also share that how 3D point of care can be a great boon to hospital setups. Thank you so much, Dr. Sir, for your presence and participation. I also have Dr. Claudio Soto, who is actually a material scientist. He is the chief medical officer with Copper 3D, a company who is actually manufacturing materials. They are dealing in filaments, antimicrobial materials, ensuring that how this technology can be useful for hospitals going forward in terms of for surgical guides, printing surgical guides, and also in terms of how it can be useful for cases where artificials can also be used in implants. So great opportunity, Doctor, for your participation and for you to also share those insights. And Doctor, as in Copper 3D is also a technology that is a franchisee technology partner in the initiative, ensuring that how these solutions can be offered to hospitals going forward. And then I have also Dr. Sanjeev Singh. He will be joining in soon. But before that, Dr. Girish Rao, if I can have your presentation, sir, and then we can go to the next, and then we will have a panel discussion towards the end. Thank you so much, sir. Thank you.
Good afternoon, everyone, and thank you, Shibu, for inviting me. On behalf of the Association of Oral and Maxillofacial Surgeons of India, it's a pleasure to be again with all of you. I've been associated with virtual planning and 3D printing technology for probably more than 2 decades now, I think. Although the buzz has happened in the last couple of years, I've always been interested in, the virtual planning, using technology for planning, and especially in facial reconstruction and rehabilitation and dental implant treatment. We have found this to be extremely useful, very predictable in terms of the kind of outcome which you can get. And I think it makes our life extremely easy for us to basically go in and do this technology. So that's my kind of introduction as to how we have gone in and started using 3D printing technology in our day-to-day practice. Right. As a maxillofacial surgeon, we see a lot of, tumors. We see a lot of congenital deformities. And these tumors could be either benign tumors or malignant tumors. And when we have a scenario like this, we have a huge issue when we subject these patients for, any surgical modality of treatment. And this ablative surgery has devastating morbidity, which could be a functional issue. People cannot chew their food, they cannot speak properly, and that has a huge physical deformity, which has led to the fact that we have taken a part of their face out, and that ultimately leads to a major psychological problem. This also has an effect on the fact that their nutrition starts deteriorating and their quality of life also becomes very much compromised. And that's where we need to sort of ask, should we do reconstruction in each and every case where we do an ablative surgery? And in the past, we have been doing some fantastic reconstruction. And the gold standard of reconstruction has been an autogenous material. That is the patient's own, be it hard tissue or soft tissue. When we have resected jaws, especially the lower jaw or the upper jaw, we've been going in and reconstructing with microvascular reconstruction. So we take bone from the leg, that's the fibula bone, or we take bone from the hip, which is basically the iliac bone, the deep circumflex iliac artery based bone graft, or sometimes we take only the soft tissue, wherein you're taking, the skin and the subcutaneous tissue from the radial forearm, that's the arm, or it could be from the lateral aspect of the thigh, or sometimes we take it from the chest, which is in the past that used to be the gold standard. And after microvascular reconstruction came in, we could get better adaptable tissues. And this has been the gold standard of reconstruction till probably about 10 years back, I would say. What is the downside about doing these mega reconstructions? Obviously, the operating time was very long. There was a donor side morbidity because we were going in and taking tissues from another aspect of the body. And of course, when you have a patient who is medically compromised, you couldn't basically take bone from the leg. Otherwise, you could lose the leg itself, or the patient would succumb with the fact that he wouldn't be able to go in for a very, very long surgery. Resection probably usually takes 1 or 2 hours. Reconstruction would take probably another 3 to 4 hours. And that is where we have been, as surgeons from time immemorial, we've been looking at how we can, give a predictable outcome, how we can do a simpler kind of solution which can give a better outcome. And that's where I think technology needs to be utilized. And today, technology has completely transformed our day-to-day lives. And we've seen this with especially the disruption which has happened in every walk of our life. And we've seen that, the photo films which were there in the past on the cameras where we had to load the cameras. Today, with digital technology, it's completely gone. Maps, I remember 30 years back, when going from town point A to point B, we had A to Z maps or the big state or nation maps, which is completely now replaced with Google. I mean, you have everything there at the drop of the hat. Encyclopedias which were there in the library, today Wikipedia has made a huge difference. And I think probably even in automobile industry, there has been a huge transformation. And I think with Uber and Lyft coming in, probably we will stop even owning our own cars. And that's where I think we need to start looking at how technology has progressed over the years. The big computers which were there, the supercomputers when we were using, probably were the size of this whole room. And today the same thing, you can, have it in a small chip. And it's interesting, people like Thomas Watson was the chairman of IBM in 1943 said, I think there is a world market for maybe 5 computers in the whole world. And Ken Oslin in digital equipment has said there is no reason why anyone would want a computer in their home. So these were bold statements which were done many decades back, and we've seen the disruption which has completely transformed our day-to-day lives. And I think if we are looking at additive technology, additive medicine, that is something which is again a game changer. And that has been used now in every walk of our life. And that's where I think in medical profession also, this has become a huge bane, I would say, in our day-to-day, in surgical aspects also. So I think when we are talking about reconstruction today, we are doing a lot of virtual planning and then we are printing it and, starting with models. These 3D models we have been using for quite some time, but with the advent of, titanium and PEEK material which we are using, and now I'm excited with the fact that we have scaffolds which are being used in which you can infuse in cells, living cells, and these scaffolds can be resorbed. So as a surgeon, I think it's such an exciting time to see how I think even soft tissues today can be printed very, very, precisely, and it can make a huge difference in managing our patients. What are the challenges which are there when we use these 3D printed technology? Number one is the fact that it's still a foreign body, and many a times you are, having a possibility of infection, rejection. That's always our biggest challenge which we need to overcome. Biocompatibility issues are also there, so we are now looking at better materials and of course the cost which is there because this technology is still in its nascent stage, and I think if everybody starts using, the cost automatically comes down. So this is, most of you here are very well known in the formative, the subtractive and additive kind of manufacturing which we are all used to, but generally to give the sense in which the workflow which happens is starting from a CT, a very fine section is what is used here. We use 0.1 millimeter sections in the maxillofacial region, and the diagnostic center, or if you have your own CBCT in our center, basically we send this into a software. So from the CT's machine, the data is basically now transformed into a software for further planning. And once this planning has been done, the design is being created by an engineer who works very closely with the clinician to get the optimum kind of results. Where our cuts are going to be made, the entire surgery can be planned completely in a reverse engineering way. The way we look at is, what is the final outcome? Ultimately, when we are talking about jaws which are being reconstructed, we also look at how teeth can be included in that and where the bite is. So the end point is basically beautiful positioning of the teeth and the functioning of the teeth So that has been taken into consideration, and then we work backwards the whole process. So that design is done, and once it's approved, manufacture happens of the patient-specific 3D printed prosthesis, and that is polished, chemically treated if necessary, and then sterilized, and that is shipped across to us for our surgical work. So that's the usual workflow which we do. So let me share with you a couple of cases which we have been doing. This is a young lady who I operated in Nimans many years back. This was a huge osteoma. It's a benign lesion in the forehead, in the orbit. That's the eye socket. And she had, because of this slow growth, the tumor was affecting her vision. The very fact that it was compressing on the optic nerve, we had to basically go in and completely debulk this entire thing and relieve the pressure which was happening on the optic nerve. Otherwise, she would have become blind. So we went in, and that's the CT, the the 3D kind of thing which we have done, and the virtual planning which has been done, and we took her up for surgery. This is a combined craniofacial resection. That's the model. And with this, basically, you can see the virtual planning, the area which had to be taken out, including the roof of the orbit, the entire forehead, and the skull bit which was involved, and the kind of prosthesis which you can see here in peak, which we did many years back. And I still remember when I started doing 3D printing technology, we weren't getting any printers in India. We could do the planning, but we had to send it either, I remember sending my first case to Germany, then we had to send it to Israel, and some cases we got it in Singapore. And I'm glad that today we are doing it locally in our own towns. And I think it'll be a stage where we will have it in every hospital. If this technology really takes off in a big way, I think every unit is going to have their own printing machines, and that's a day, a point of contact kind of situation which we would like to see, a point of care, sorry. That is what which we should be looking at. And that's the resected area which you can see over here. That's the prosthesis which we have printed over there. And that's the outcome. You can see the way in which a complete transformation. I put the scar in the hairline so you can't even see any scar on the face. And from here, where she had this huge tumor, you can see the kind of transformation. The precision is unbelievable. I mean, to get this kind of thing with 3D printing technology is such a boon, I would say. Another lady, I will just like to share 3 cases, and then I will have some discussions. This is another lady whom you can see here. The jaw on the left side is completely gone. It's not there at all. She had a congenitally missing condyle. That means that the jaw joint is not there at all. That's the CT which we have got in the planning stage. This would have been the normal condyle. This is the coronoid process. The back portion of the jaw and the angle of the jaw is completely deficient. She was very much concerned, although she could open and close, she was very much concerned, and she wanted just a bit of filling in this angle, which could actually improve her psyche. Although, we didn't think in terms of, in fact, I wanted the joint itself to be replaced, but she was very keen only to get the angle of the jaw restored. And that's where you can see the way in which the lower border of the mandible, this bit which we have planned, again, everything is done virtually. We mirror it from the normal side, that's the right side, which is the normal, to the left side, and that's how we have increased this height here. We've defined the angle of the mandible, and that's the prosthesis which we have got. So that's the titanium framework which we are putting it from the lower border, and that will augment the bone. And that's her during the surgery. You can see the way in which we have restored it, and that's the fixation which we have done using titanium plates, and that's the post-op OPG. If you see here, this is the angle here, and that matches exactly to this angle. So that precision is possible only and only with virtual surgery today. And that's the kind of results which we have been able to get it, and the kind of angulation. She wanted this fullness, which we have been able to get this. This is another young man. Again, he was basketball player, I think, came to us from another state, and he was very, very keen. He was diagnosed with a jaw tumor, a young man. And no, sorry, he was a football player, and he did not want anything to do with the leg. Although I offered him, I will take, this is the jaw tumor, I'll take the bone from the leg, the fibula, and do a microvascular reconstruction, put implants into that. But he said, Doc, it's going to affect my career. I want to be a professional football player. So that's when we decided to try 3D printing technology, and that is the scan you can see. That's the destruction. This is the 3D image of the CT, which we have done the 3D reconstruction. This image is now imported into the software. There are a lot of open source software, or you can use specific custom made ones. That's the 3D printed model, what you can see here. We did a model, and these are the cutting guides. Today, the cuts are so precise, you can actually have these guides and make such a big difference. So I know exactly how much I'm going to cut. And once we have done that, we mirror the normal side to this side, and we're able to give the form of that. And that's the reconstruction area which we are planning. And that's the titanium prosthesis, which you can see here, which is going to exactly, precisely fit where we had planned. So that's basically 3D printing. And that's during the surgery. You can see the guides over here. And using a fine saw, I basically make these cuts here on both ends. That's the nerve which I preserved. I didn't want him to lose his sensation. You can see the fine cut being done. I preserved his condyle. That's the jaw joint. And that nerve has been completely taken off the tumor. And once it's been done, this is the 3D printing technology, which we, the patient-specific 3D printed prosthesis. And I've done these perforations so that I can put some bone graft here. These are synthetic graft, which we mix with patient's own blood, the PRP, that's platelet-rich plasma. We mix it, which has got some growth factors. So we get the continuum of the bone in which later on I can go in and place implants. And that's the final CT scan, which you can see the way in which we have been able to get the contour. The entire jaw, which has been resected on the right side, is mirrored now with this patient-specific implants, and we have been able to get fantastic contour. This is post-surgery, immediately after surgery. We're talking in a couple of weeks' time. I've hidden the scar in the neck, and now if you see, hardly you can see the scar at all. That's the shape. And, the outcome has been phenomenally good. To get this kind of thing requires a lot of training, but I think if we do it right, there is no problems at all. So I believe 3D printing technology is a game changer. And I think the most important thing which we need to look at is that everybody brings into the table their own expertise. I am a maxillofacial surgeon. I work very closely with prosthodontists and other medical and surgical specialists. So we work together. But today, bringing an engineer in, a software engineer who helps us in planning, and bringing in the industry together, bringing in academia together, all these things can make a huge difference. And ultimately, our goal is to get a happy patient. This patient should get the best in any part of the world. And that's basically a basic right of any human being. Getting, an absolute right to the best treatment which is provided anywhere in the world needs to be done locally. And that's the philosophy with which we maxillofacial surgeons are making a difference to our society. So let me end my presentation over here, and I'm open for any questions or any discussions. Thank you.
Thank you, Doctor. Thank you. I think it was very detailed. Every presentation I have been able to experience from you some great cases that you have been working on. Thank you so much, Doctor, for your insightful thoughts shared through the presentation and also the work, because I think even surgeries need innovation. You've been really working on those terms of formulation to then help your patients going forward, in terms of helping. So, Doctor, now we also see that we are looking at new materials coming into the space. In fact, we've also been discussing on this, the titanium being the best opted solution. But when it comes to bone materials, when it comes to malignant cancer, and I see a lot of cases in onco that we see. How do you think of working on these also looking at materials like hydroxyapatite or various other bone materials in terms of an option, or are you already do you have a chance to already explore that right now? Because we're working on that kind of a module too.
I mean, we are very, right now we are only dealing with titanium and PEEK. These are the materials which we are working right now. We have had some fantastic results. But again, the biggest concern, especially, I'm spearheading a whole project for mucormycosis. I mean, during the second wave of COVID, a lot of cases of mucormycosis, and the whole face was, completely eaten away. I mean, we had to resect the jaws, the eye. So we are now using a lot of 3D printing technology over there. And in some of the cases, some of my colleagues who have also done, they've had issues with infection. And one of the biggest concerns, as I told you earlier, is the fact that when you have a metal there and when you don't get good amount of soft tissue cover, that is where you have issues with infection. Yep. So we want two things. One is materials which are, I hope we can get that one day, which are resistant to any infection. That's the biggest. I mean, today there is a lot of buzz on that. I mean, materials which leach out antibiotics and things like that, or bacterial repellent kind of biocompatible materials. So that is one area which we are looking at. And the second area which we are looking at is bioresorbable scaffolds. And if we can work on that, I mean, still it's very, very, I know in IISc and in IIT Mumbai, there are, in the labs, there is a lot of work which is happening. And we are very open. I mean, I head a group of about 8,000 surgeons who are passionate about facial surgery. And we embrace technology when there is a possibility that it can make a huge difference to our patients. So we are very, very keen on doing multi-centric trials on that. So I'm very, very keen that our association itself takes up a big project, and then we do these things together.
Right.
So I'm looking at if industries can help us in funding for doing research, for doing clinical trials. I'm very, very open for these kind of things. So we are excited about this. The other area, which is even bigger, is probably dental implants. This facial surgery is not that much. But when we talk about dental implants, when, in a tooth is being replaced, almost everybody loses a tooth at some point of their life or the other. And then, the bone needs to be built around that area. And then we go in and put an implant. So there is a huge potential. I mean, the number of clinicians who can work on that is something, it's unimaginable. And that's where we are very, very keen on using this kind of technology. And bioresorbable scaffolds would be a boon in such areas, especially in alveolar bed preparation, building up the site for an implant placement.
Right, doctor. And so are we also working with, 3D Graphy is more like a consortium. And it's been a privilege for us to also connect with key respondents. In fact, Dr. Vikas Jain, who is an orthopedic surgeon, they also have a center very recently that they've started, having beautifully set an orthopedic service center. But I'm sure they will also look at offering solutions to you, sir, going forward in terms of actually a center, even in head and neck, going forward. So that's the kind of attraction that we are seeing in terms of many active respondents and service centers coming out in the country, coming up with new materials also. As you rightly said about the bioresorbable materials, yes, we have respondents in Dr. Jayesh Ballare, if you know him. Last time we also connected in one of the events. He's doing a lot of work there in bioresorbable materials also, doctor. And today also I have an opportunity to invite Dr. Claudio Soto. He's joining from Chile, doctor. And he's also done some work in the zygomatic arch or the nasal. There was an implant where he has used antimicrobial materials. They're manufacturing these materials and very actively sourcing these materials. And let me invite him, doctor, so that you can also have a look at his presentation. Also understand, where all we can really benefit working as a consortium going forward. So,
if I can make a comment on that. I mean, we have learned a lot from our orthopedic colleagues. when it comes down to, over the years, we're talking decades back when they started doing plates and screws. And when we very closely, we adapted it into the facial region. So I think there is so much of symbiosis, which every specialty needs to work together. And I'm very, very keen to learn a lot from Dr. Vikas, from his input too, and from others like Claudio and whoever is there in this group today. I think that's where we can all work together and learn from each other with our own experiences, and also with all complications which we face. And that's something which I believe in sharing, and we know where we need to, tighten the loose ends so that we all move forward.
Yes,
Thank you.
agree, doctor. Fully agree. Yeah.
Thank you, Doctor. So may I now invite Dr. Claudio Celli. Very good morning to you. It's early in the morning, Doctor. Thank you so much for your participation, and I'm sure the session would be interesting for a lot of them to also know in terms of the solutions that you're offering. Please, Doctor.
Thank you for having me this morning here in Chile, and good evening, everyone. Let me introduce a little bit a big problem, a big issue. 10% of people who are admitted in the healthcare facility get hospital-acquired infections, and at least according to the literature, 50% is due to the fact of the high contamination load on medical device and surface, at least 50%. And according to WHO, 10 million of people will die because of the antimicrobial resistance by 2050. Okay, it's a very, very huge problem that as a clinician we need to address. So following this argument, we need new approaches, and that was the reason because we found a copper 3D in 2018 in order to produce antimicrobial solutions and materials for biomedical 3D printing and help to save lives. This is an example of our first material, antimicrobial TPU, called commercially MDFlex. And this material could be transformed into an antimicrobial insole for diabetic foot, or an orthosis for this adolescent in Italy who suffered epidermolysis bullosa, or low-cost antimicrobial 3D printed hand for Margarita, a girl who suffered congenital amputations, or an antimicrobial toy for Javier, a child with an immunosuppression condition, and now he can play with this antimicrobial toy made from our material. On the other hand, we came up with this antimicrobial resin, and this material, this resin, could be transformed into a surgical guide for high complex surgeries, orthopedic surgery, by the way, or cut a device who guide the surgeon in order to cut the bone. We developed here, it's a very small country here, Chile. We developed, 21 surgeries with a high precision in terms of less of deviation of 1 degree in the position of the prosthesis. We saved 60 minutes in the duration of the surgeries. So we are glad to develop this type of solution here in my country. GRAPHY LAB, these are two materials. PL active, it's based on PLA, a biopolymer, plus this additive based on copper salt with antimicrobial properties, of course, and then MDFlex, our flexible material. You can see, for example, a wrist orthosis made from this, and our this is our resin. And you can see the design, the SLA 3D printer, the medical device, and finally enter in the operating room. How it works, we blend the raw material, PLA or TPU or the resin, plus this additive based on copper salt, and the copper ion. It's the very, very low amount of this copper salt, very, very, very low. The copper release an ion that affects the membrane and the genetic material of the germs and kill them. We tested the antimicrobial performance in different parts of the world, in Chile, US, UK, Dubai, according to international standard 22196. It's fully biocompatible according ISO 10993 with scientific validations in peer-reviewed journals and FDA and EPA regulatory compliance. Some customers, 3D Buyer in the UK, 3D APAC in Australia, from Futura in Europe, Atom 3D in France, 3D Print Life Matter Hackers distribute our materials in the US, Royal Prince Alfred Hospital in Australia, and hospitals regarding trauma patients here in my region, Mutual, Clínica Alemana, etc. And Precise in Dubai, by the way. Some projects and applications, oral facial stimulator for a child with neurological conditions, and this is a covered surface made from Generation 3D in Dubai, because this is the problem. This is the hospitals are a highly trafficked environment with a high possibility to contaminate the surface. And other applications is a collaboration with a clinic, maxillofacial in Brazil. They are using our flex material to develop some type of implants, and they found a very, very interesting results, because they noticed that the result in terms of rate of healing and rate of regeneration, of the tissue, it's higher, it's faster than the regular material with zero infections. And finally, the future, we won a very competitive grant here in my country to develop an antimicrobial polymer in a powder form for SLS. So this is a prototype of the titanium, antimicrobial titanium. Maybe in the near future, in in a year, we will come with new polymer for SLS, antimicrobial, biocompatible, and fully implantable. The core team, Daniel, Claudio, myself, and Andres, we are develop our company here in Chile and different parts of the world, and maybe why not in India. Thank you for having me today.
Thank you, Dr. Claudio. I think it was a presentation which covered almost every area of medical applications in terms of the offering. Dr. Girish Rao, sorry, if you have any questions, because since he had actually mentioned about this, it's an implantable material, Dr. Claudio, that you have been using it?
Here in Chile.
This is an FDA approved.
In Chile and Europe and US, the material are using in not in an implantable form, But in Brazil, they are developing all the research, and they have more than 20 patients using as an implantable. Now we are develop a material, as I said, in order for other technology, SLS, to produce medical device in an implantable form with antimicrobial properties, because copper is very interesting function, because the metal have the capability to produce angiogenesis, avoid the biofilm, as you know, the mechanism of resistance of the bacteria. So it's important. We are so glad to try to develop solutions for clinicians, and for biomedical 3D printing.
Okay,
I know if
great.
are you following me?
Yeah, I got your point. Yes. Any other questions from the audience? Dr. Girish, any queries that you probably would have, or Dr. Vikas?
Yeah, Dr. Claudio, I would like to ask you one thing. What would you do as far as antimicrobial solution is concerned when it comes to metal? Because even Dr. Girish and even myself as an orthopedic surgeon, our main concern is implantable devices, predominantly titanium, and we need to have some solutions as far as antimicrobial properties is concerned.
We know the road to produce biocompatible materials, and because it's a very tricky way. But why? Because we need to test all the tests regarding the biocompatibility using the FDA regulatory norms. So that is the reason we think in 18 months maybe we will come with this new product in order to address the possibility of contamination of medical device for orthopedics solutions. Right now, we are in the R&D way, proving different polymers with different additives based on copper, organic additives, and trying to figure it out. The antimicrobial capability, and when the minimum viable product should be ready, then started to the biocompatibility test. I don't know if I answer your question.
So, there's anything you have thought in terms of silver nitrate coating or gold coating? Because in India, silver nitrate coating and the gold coating is assumed or is marketed by various metal implant manufacturers as far as a sort of antimicrobial. I don't know how much helpful it is.
Yeah, we studied the silver as metal as an antimicrobial solution, because the evidence says if you compare the copper and silver in terms of antimicrobial performance, the copper is better because it works in different environments, and silver needs to be antimicrobial in a very specific conditions. When we tested, for example, the coats made from silver and the coats made from copper, in my opinion, and the evidence says that the copper it's better and it's cheaper.
Okay. Thank you, Claudio. I think, Shibu, we can also go ahead with other presentations. Thank you, Claudio. That was really helpful.
Oh, thank you.
Yeah, Dr. Vikas, and thank you, Dr. Claudio, for that presentation in detail. Uh, Now, let me introduce everybody to Sarup Chand, who is the director with Edotech Information Systems. Sarup Chand, as I mentioned earlier, they are also into 3D technology in terms of 3D machines and technology, also dealing in various different machines in terms of the offering. So they are also one of our franchisee technology partners in terms of want to offer solutions to hospitals going forward with 3D GRAPHY labs that we want to set up. And we will, once Mr. Sarup Chand has actually shared his inputs, we will also have a panel discussion as scheduled. Dr. Girdhar Gyani also will be joining in few minutes, and we will discuss the course forward. Yeah. Thank you so much, Mr. Sarup Chand.
Good evening. Okay, I am not from the medical field, but we do a lot of work in the medical area, and as a company, we hold a couple of patents for the burn and deep wound patients treatment using the 3D printing. Adroitic as a company, and I'm just putting my understanding of the use of 3D printing in the dental, medical, and other areas. So, Adroitic has been working to enable its customers to leap forward in technology. So, we are a technology company. We provide services and we also provide solutions which help our customers, doctors, engineers in ensuring that whatever is their idea could be materialized. So today we are close to about 400 people, and of them 200 plus are engineers who are doing the design work. We are a 30-year-old company with offices spread across the country and also in Detroit and Cologne, Germany. We work in 3D printing for prototyping, for education, for different areas of the medical, defense, and other things. We work in IIoT, robotic automation, and CAD, which is engineering. Today, we as a company, we have equipment from HP, which is a multi-jet fusion technology, Stratasys, which is a polyjet, FDM, carbon composite, DLP, SLA. All these machines exist with us. We also have Hyrel, and this is a machine which we manufacture, which prints in silicone, PEEK, gel, and different type of polymers. We also have a bioprinter which can do the tissue scaffolds quickly with the biogels which are available from different universities and available in commercial level. And we have the corresponding software for scaffolds where you can specify the size and the type of a scaffold one would like to work with. We also work with a metal machine, which is a powder-based multi-material metal printer. It enables you to both do the production level metal printing as well as work in terms of research on different metal powders. So it can work with materials like titanium, steel, and also various alloys which are useful to work with copper or chromium or this different material. We also have one more machine which we developed ourselves, which is called the Smart One Plus. This is a multi-material machine which can print in polymers, but more important, it can also print in ceramic. So there is a machine from Stratasys which is called the Digital Anatomy 3D printers. The good thing is it gives you the color output, which is very useful for surgical planning, and it has not only just the color planning, but it also has a functionality. So since it has a functionality, you can vary the density, you can change the flexibility, and you can create the material almost as if it's inside the body, the same behavior as the tissue and the various organs, the way they work with. So it has a functionality as well as give the true representation for surgical planning. In addition, one of the problems which many of the hospitals and the doctors faced was how do I do the conversion from DICOM to a 3D segmentation, which is critical sorry, which is critical for doing the planning work. And most of the time one had to depend on engineers and wait for days together. In this case, the segmentation is driven by the AI tool, and the moment you feed the DICOM file, in less than 6 to 8 hours time, you get the complete segmented model, which can be seen by you, can be planned on the basis of 3D model, and if necessary can be 3D printed on any of the systems which we have. So as a company, we work in CAD, we work with different materials. Some people, Dr. Girdhar or Girish also mentioned about PEEK. We do work and print parts in PEEK, which are practically usable for making the jigs, which are usable in making the surgical plan and the models which are necessary, and the metal machines can be used for making the implants. So if we look at the biomedical applications, it could be skull patches, which could be worked in ceramic as well. It could be headphones, hearing aids. It could be cleft palate correction. It could be crown and bridge, dentures, implant drill guides, orthodontics, night guards, custom neck braces, custom sleep apnea masks, spinal cages, pre-surgical medical models, which can be used both for education as well as for planning. Because whatever little I understand, it's very difficult to explain the complex cases because there is no model subsequently available with the doctor to explain and teach the student and also the patient of the outcomes which are likely to happen. So 3D printing become very useful both for patient education as well as for the subsequently for the student education for dealing with complex cases. It could be for orthopedic braces, hand braces, which Dr. Girish also showed some of them, or even Dr. Claudia showed. It could be the personal, since I showed you the digital anatomy printer, you could also do the practice on the medical models because the behavior and the of the model is exactly the way the bone or the tissue or the muscles will be working. So you have the personal surgical guides, prosthetic limbs, prosthetic fairings, custom orthotics as well as insoles. So what is the benefit of it and why should you go for all this trouble? It, as both the speakers before me have already emphasized of the precision, with predictability, ease and the high accuracy which can be achieved, and also the reduced time which can happen. It can also be for medical supplies like nasopharyngeal swabs or any other such requirements. It could be for protective equipment, it could be for custom specific implants, and all of it has helped in reducing the surgical operating time and precision, as I think with the use case studies it has already been emphasized upon. So this is an example of a DAP machine, which is the digital anatomical printer, and if you can see that the complete surgery can be actually operated on the part which has been 3D printed and then worked with. The surgical guides can be tried, the accuracy can be done, the biomechanical properties are exactly the way they are seen inside the body. So this is true for the tissue, it is also true for the bones. And wherever the cartilage is, you can get in between the cartilage and you can get the bones. I'm just showing you a few of the examples of the bone features which are 3D printed using the DAP system. And it's in color as well. It's a growing line, as we can all see. Today globally it is growing by close to about 21% year on year, which means the medical equipment manufacturers, the surgical planning, the hospitals are all trying to work with this field in terms of how the outcomes can be improved upon. There is another area which is the precision medicines, which are also being now developed. Instead of giving the fixed doses, you can also do the custom medicine preparation using the same 3D printers as the bioprinters. So we have worked with a couple of customers who have taken a bioprinter with multiple extruders to give the specific patient driven medicines. I did share with you the orthodontic, dental, hearing aids, orthopedic applications, as well as the prosthetic applications from insoles, braces, cranial orthosis, prosthesis, and different applications which can be done in the facial shields, ventilators. All of them are now being done using the 3D printing in the hospital and for the different patients per se. These are some of the examples of the jigs and fixtures, and I think Dr. Girish mentioned about how the fixture has helped in reducing the time. So one of our dental, the maxillofacial surgeons use this extensively for tibia bones to be cut precisely during the surgery process. In the COVID period, we worked with a lot of medical equipment manufacturers to make airtight walls and in large quantity, as you can see it on the extreme right, that how many pieces could be done. So in 24 days time, we supplied close to 130,000 parts, which were used for the various equipments which were needed for the during the COVID period. So who needs it? If we look at it, the senior surgeons know most of it. So only in 10% of the complicated cases they would need it. But if you look at the middle-aged surgeons who have gone through limited experience, at least they would need for 30% of the surgical cases. And this is proved globally. So I do work with some of the doctors in Mayo Clinic as well. And they all say that the people who are with about 3, 4, 5 years experience typically would need this planning, and it would help them extensively. Of course, the students will need it to both understand and learn from the senior surgeons and practice on it for a long period of time. Where is it used? It's not that in all cases. We have seen that in pediatric surgery, it is more often used and very useful. Oncology, it is very often used. Neurosurgery, it is used. And in cases like aneurysm or wall treatment in cardiothoracic surgery, it is very, very beneficial. Of course, Dr. Girish has already mentioned about the facial reconstruction and scoliosis repair, which are equally important in the case of where the 3D printed surgery planning has become very useful. So, if we look at it, it is for anatomical models, for fixtures, it's for surgical instruments, it's for prosthetic, it is for dental, it's for non-resorbable patient-matched implants, manufacturing methods for non-patient implants. So you can create the prototype before the full implant manufacturing is done. There are different methods in terms of technology. Typically, powder bed extrusion and the material extrusion, which is the FDM technology, are being used extensively. The VAT polymerization and the material jetting are other two technologies which are being more popularly used. That's all I had to say and share with you in terms of technology, who uses it, why it is used, and type of infrastructure which we have as a company, both for providing the services as well as to provide the solutions to the hospital or to the doctors. Thank you very much.
Yeah, thank you so much, Mr. Swaroop, for your presentation. I think it constitutes of a very large area of services that you are offering, including the machine and the technology. I'm sure for hospitals looking at various different solutions, it can be of great help. I have Dr. Girdhar Gyani sir actually who is joined with his start a few words. We missed him in the start of the session. But sir, thank you so much for your presence, sir. And we would have one more presentation, sir, that will be on the software bit, and then we will actually have a formal introduction where we can make the announcement of this 3D Graphy Lab setup with the AHPI as we propose to do. And also, sir, would also invite all the key respondents and technology respondents to join in our AHPI conclave to be held on 10th and 11th in Jaipur.
Yes, please.
To ensure
Yeah.
that how it can be of great opportunity for us to connect with respondents. Yeah. So if you, I will invite the next speaker, and then we will have this announcement and also a panel discussion for all of us to join. Dr.
Right,
Girdhar,
right. Okay.
Is that
Yeah,
okay?
I'm there. Right.
Okay, sir. Thank you so much. So may I now invite Dr. Kareem Glenn. Kareem is actually the business development manager with Simpleware Synopsys. Also in India, they have a distributor partner by the name IMS, who is actually supporting and also promoting the technology. A very good morning to you, Dr. Kareem. I think it's midnight there, almost.
It's just early morning. I'm in Washington, D.C.
Early morning. Yes. Okay, great. Thank you so much, Doctor, for being a part of the discussion. And Dr. Kareem is also one of the key respondents offering solutions in the software in the medical space. He's actually been actively sourcing information and also offering solutions in point of care in hospitals with this kind of extensive research on the subject of the software piece. Dr. Kareem, please, you can start your presentation. Thank you.
Yeah, I'm sorry. I'm struggling a little bit to see how to present or to share my screen. Is there a button here?
Yeah. So, Doctor, when you see on a lower down on your screen, you have an option which is a camera icon. Besides the camera icon is the screen share. Yeah.
Very good.
Yeah.
Oh, and let me just get the right screen. There we go.
Yes. So we can see your screen. That's it. Perfect.
All right. Perfect. There we go. Great. Yeah. Well, thank you, Dr. Shibu, for having me. My name is Karim Gench. Actually, slight difference. Recently, I've changed. I've moved positions into product manager. Previously I was managing the sales team within the Simpleware team for the last 10 years, and I've moved. As of actually Monday, I will be a product manager. So moving away from sales, more into strategy, higher levels and vision, partnerships, things like that, within the Simpleware group at Synopsys. So just to clarify that slightly, just a little change in my title. But yeah, today I'll just give a very brief overview of Simpleware software and our 3D software solutions for the 3D Graphy labs in hospitals. So just to give you a little background on the Simpleware product group, we are part of Synopsys. Synopsys acquired Simpleware back in 2016, so it's been a while now being part of Synopsys. I've been with the Simpleware group for 11 years now, and we develop software and we convert 3D images into models. That's the main. The easiest way to describe us is going from 3D images, whether that's CT, MRI, micro CT, other modalities, converting those 3D images into models, and however you define models, whether that's for things for like measurements, STL or 3MF files for 3D printing, NURBS, CAD geometries for design, or finite element meshes for simulation. So again, 3D images to models is what we do, and we license this software, and we can develop solutions as well. So We have dedicated sales, support, and services teams internationally. We have a global presence, and we work with customers in clinical life sciences primarily, and then in things like materials and manufacturing as well. So for this presentation in the life sciences, I can on the left is within this arrow box is just the basic workflow, which I'm sure many people here are familiar with, and it's been discussed in previous presentations. But within the Simpleware software, you import your images. We have segmentation tools, everything from fully manual to fully automatic, using AI, machine learning based AI tools. From there, you generate your model. You can do your analysis and reporting, and then you can export these models for different applications. Within the life sciences, ours of primary focus for this group here are the top two for implants, guides, and surgical planning. So anything that's patient specific, and then also point of care 3D printing within the hospital. So it's typically anatomical types of 3D printing, which was just discussed as well. A third area for us is in silico clinical trials. So this is when you go into simulation, finite element simulation, and things like that, which isn't too relevant for the folks on this call here. So our clients consider Simpleware to be the best-in-class tool for image segmentation. We've been, since 2000 was when the company was first founded, so our algorithms have been very robustly developed over a long period. We have AI-enabled automation, analysis, reporting. You can fully customize the interface with scripting, GUI, and things like that. And we can export STL, 3MF, CAD, and simulation exports, as I mentioned earlier. So that's the overall workflow and where we fit into, which is the image to model, and then you can export and go along your workflow for implants, guides, and surgical planning, or point of care 3D printing. So our main flagship tool is Simpleware Scan IP Medical, and that's for typically for point of care 3D printing. So this is our flagship medical image processing platform. It is CE marked, and we do have FDA 510K clearance for it. And this is the platform for that we can license, and that most of our users in this domain use. And then also just to mention, in terms of our 510K clearance, we have 510K clearance for various printers, for Formlabs, HP, Rise, Stratasys, different printer models, their materials, and different anatomical regions. So this is the clearance that we're required to go through, at least here in the US, for the FDA clearance. Really, it depends on how relevant that is to folks in India, but this is some clearance and regulatory processes that we've gone through. So Simpleware software, what does it do? So this is just a brief overview here if you look from left to right of what we can do, is where you can import the image data, visualizations that can do volume rendering, things like that. Then we have image segmentation and processing. So that's typically the most manual part of the process, but we have tools to enable that and help try and speed that workflow as much as possible and reduce manual time effort as much as possible. We have different measurements and analysis tools, center lines, cross-sectional areas, volumes, contact areas, all sorts of measurement tools. Then as well, you could have some CAD and image integration. So if you want to import a CAD geometry, position it, look how an implant fits within the anatomy, such as a stent within an artery, things of that nature you can do for surgical planning. And then model generation, again, STL, 3MF, all finite element models, CAD models, and then exporting that for point of care 3D printing. And within Simpleware Scan IP and Scan IP Medical, we have our 3D printing toolkit. So this is a toolkit we've developed that's primarily focused on anatomical 3D printing. And this gives you all the tools necessary to prepare the anatomies for the printers. So you can do things like create support structures. You can map the density of the bone to the surface. You can cut, you can hollow, emboss text, all sorts of things like that that are typically done for this workflow. So it's all within one software platform. So just to reduce going from one platform to the next platform to the next, we've tried to consolidate as much as we can within ScanIP, so you're not required to buy multiple softwares to get an anatomical 3D printed model done. In terms of automation, we have off-the-shelf tools that can help automate your segmentation. So we have a tool called AS Ortho CMF. So this is within this tool. It contains automatic segmentation tools for the ankle, hip, knee, shoulder, and CMF when looking at CT. And then we also have knee MRI. That it could automatically segment. And then AS Cardio. So this is automatic segmentation landmarking for 3D and 4D heart CT. So these are turnkey add-on modules for ScanIP Medical, and then it can speed up production significantly. How far along the segmentation process it gets you depends on the data. It can get you anywhere from, 30, 50% of the way there to 100% of the way there, depending on your image data. But the idea here is to eliminate the need to start segmentation from scratch. So that's a basic overview of the software, and then to quickly go over a 3D printing example. This is an anatomical 3D printing in the hospital that we did with Nicholas Children's Hospital. We've done webinars and joint work with this group, Dr. Bob Hannon, down in Florida, down in Miami. So this is an example of a patient who had some heart pathology. So they were able to import it into Simpleware, use the AS Cardio tool, and automatically segment it. And then our 3D printing toolkit, they're able to add supports, add the base, emboss the text, and prepare it for printing. So the manual workflow was about 2 hours, but within Simpleware, with our automated tool, it was about 15 minutes. So we had a big time savings on this particular case, using Simpleware as Cardio, doing connectors, debossing, embossing, and then also creating a cylinder primitive. And their engineer, we have a little quote from him saying, our new engineer segmented it. Well, he hit the go button on AS Cardio and then added the base and supports very quick. So this was their biomedical engineer within the lab. And they continue to use it regularly within their 3D printing lab. And this particular one was done on the Stratasys J5 Medijet, but the group also has the digital anatomy printer as well. So they can use us within both of those machines. So you can get a free trial of Simpleware, have personalized demonstrations. We have videos, webcasts, all sorts of stuff on our website that you can download. You can contact us. Actually, we do have a partner within India, IMS, Integrated Microsystems, and they are our reseller within India, and they're experts on Simpleware, and they can help you get going, benchmark, and deploy the solution within your 3D printing application. So with that, I want to say thank you and pass it back to you.
Thank you so much, Dr. Karim. You also mentioned about your recent development with the AI tools that you have also prepared for the software. How is that actually shaping in? And we also heard from Mr. Sarup regarding the tools which can probably help you to. It's more like an automated kind of a solution, because today we want to make things more simpler and simplified in terms of making it more convenient for doctors. Because now we are at a time when we are looking at customized solutions for doctors to get involved in this process. So beyond a designer, if doctors can make this more conveniently easy to handle, how does it work? And do you have something of those on those lines also?
Yeah, so those automated tools I mentioned, those are just add-on tools to the software that can be licensed and added on, and it again, I'm cautious saying that it makes everything automatic. It depends on your data. So, these are machine learning based AI tools that are trained on specific data sets. So, for example, with that heart, that was the model was trained on adult hearts. This heart that I showed was actually a 16-year-old, and it worked out really well. They actually, on a separate case, they tried it on a 2-year-old heart, and it didn't work quite so well, but it missed one of the ventricles and part of the aorta. But it took an extra 10, 15 minutes for the engineer to clean that up and then send that off. So again, it's how automated depends on your data and your AI tool. So we have off-the-shelf tools that are pretty general AI tools that work, but we also do fully customized AI tools. So this is where we work with the customer and their data and train a highly specific AI tool. So this is for customers who have a throughput of hundreds to thousands of images per month. So for example, one of our customers, Corin, this is more for patient-specific surgical planning and guide design, and they do about 600 cases per month. And using our fully customized solutions, we're able to reduce the time about 94% to make it a single-click solution with them. But the reason we can do that is because they have the data, they have the focused context of use, and we can train the model to deploy that for production level work. So if you're in a lab and you're just starting off with 3D printing, and say you get some craniomaxillofacial, you get hip, knee, ankle, all sorts of different anatomies, you have a lot of trauma, a lot of osteopenia, or you want to do different organs, and it all comes across your desk, that becomes very difficult to automate. There are off-the-shelf tools that can help, but yeah, it just kind of depends on your application and in terms of how automated it can become.
So I would like to ask a question to Dr. Karim. Hello, Dr. Karim. This is Dr. Vikas, and we would be working a lot as far as preoperative planning is concerned and using the softwares. So one question that I want to ask is this software an open source? So that suppose if I want to do part of machine learning, or I want to use some form of machine learning to automate certain part of my planning. So is it possible on your software?
No. So our AI tools, they are closed. We do as a service create the automated solutions for our customers, but we don't have, say, for example, a toolbox where you can train your own models. There's NVIDIA Clara that can do that. NVIDIA has some nice open source tools if you want to train your own models for the segmentation.
Yes.
But again, I guess the limitation, not
the segmentation. Right. So we are going beyond segmentation now, Dr. Karim. So let me see. Suppose if it's a patient who's requiring a knee replacement surgery, right? And I want to design cuts. So I'll be doing a lot of preoperative planning. I'll be marking the points on the various anatomical regions. And then would plan out the cuts, and these cuts would be very specific to a patient, right? So then for those sort of a planning, if we are allowed to do some form of machine learning on the software, then it is quite possible that we can further automate those surgical plannings.
Yeah, I mean, currently our AI is just for segmentation and landmarking. So landmarking is also, I should mention that too, is pretty important, because with landmarks you get measurements, everything like that, and you can set cutting planes and things like that through scripting to automate that. So that's what our customers currently do, but it's a closed system. It's not an open platform for people to train.
So we have to go still a step ahead, because once you are enabling us to do automated landmarking, then the next part is now to plan out the surgery on it, right? So would your engineers enable us to do that as part of the process, or how do we go ahead?
Yeah, so I mean, with just say you create your landmarks, and from your set, so we have customers we've developed custom solutions for, where we train for the segmentation and specific landmarks that they want. And once they get those landmarks, it's just a matter of writing scripts to, say, create the cutting planes, or designate this is where you drill and that kind of stuff. So for that, it's just a matter of scripting. So it's not even AI. AI is used just to get the landmarks, and then it's just a matter of making sure you, from those landmarks, you can create kind of the guides and the cutting planes and things like that you want, and feed that into, say, a design program to do that. So With us, the AI ends at the segmentation and landmarking. That's not to say we're not going to go beyond that, but for now, that's typically where it is. And then customers leverage our scripting to build that into the automatic tool.
What level of hardware is required to run your software?
Pretty standard engineering laptops work. I mean, now with the AI tool, the only without the AI tools, pretty much any standard engineering laptop would work. With the AI tools, you need an NVIDIA card with 4 gigabytes of memory in it. But even that is starting to become standard. So it's nothing too hefty. You don't need like HPC or anything like high power computing or anything like that.
Yeah, because there are various other softwares in the market which is requiring a very difficult hardware systems, to manage those softwares.
Yeah. Typically the more RAM you have, the better. I mean, at least if you have 64 gigs,
RAM,
32.
16,
16 is okay. 32 plus is the best for sure. But the more RAM you have, the better, because it's very graphically intensive.
Okay, understood. So yes, Shibu, you can go ahead.
Yes. Thank you so much, Dr. Karim, for those inputs that you had to share. Simpleware Synopsys is also our franchisee technology partner. So as we progress, there will be a lot of inputs that we will also gain, and attraction can be built around in terms of how these solutions can be taken as an opportunity for the end user to benefit. Thank you so much, Dr. Karim. Gentlemen, I think the larger the context was to see that how each of these technologies. I had a great opportunity to have Dr. Girish Rao, the Secretary General with AOMSI, the Association of Healthcare Providers, the Association of Oral Maxillofacial Surgeons of India, also share his presentation with some of the case studies. And likewise, many doctors are already using this technology. So it's not new. But I think for something like an initiative where we would also want to work with hospitals, because that becomes a platform where every medical specialization can gain and benefit from this particular services. I'm sure there'll be much to achieve. Also to make it more convenient for patients to also experience this technology. So because we are not looking at X-rays anymore, even beyond X-rays in terms of also having prototypes being one of the experience for patients to actually have a feel of the anatomy and then to understand the case better, because globally it's been well adapted. I mean, that's a standard practice. And I think we should also be activating it from India, a country which is very dynamic, and it's important that this technology should be well adapted. And I'm sure as a platform with 3D Graphy Lab working with the HPI, I'm sure the larger intent is to do that. And thank you so much, all our partners who have also actively been there, sharing your insights and also supporting. And I'm sure we will take the road and the pathway is set. Now we will also have a short discussion, maybe for 10 or 15 minutes from each of these respondents, and then have these inputs to be shared eventually in our platform called 3D Graphy News, which is also a conscious effort in terms of promoting the technology across sectors. But since now our focus is on medical, it will be very interesting to know each and every respondent's opinion and seeing how their center can be of value to be offered. So may I now invite Dr. Vikas Jain, who is the Chief Technology Officer and the Strategic Advisor with Orthotech India, to share his opinion to start the discussion. So the topic and the title is 3D Graphy Labs, 3D Technology Solutions for Hospitals.
Yes. So thank you so much, Dr. Shibu, and thanks for all the panelists, and thank you, Dr. Girdhar Gyani, who was open-heartedly accepted you as 3D Graphy to be a lifetime partner. I have understood the way you have been trying to democratize this technology. So what I understand is, being from the medical fraternity and being an orthopedic surgeon, which I see is where we have one of the largest demand for this particular technology is concerned, it is very important that big hospitals where there is tremendous amount of work, where the surgeons are quite qualified, and we introduce this technology to those surgeons, and those surgeons have to get sensitized as to how to utilize the importance of this particular technology in their day-to-day work. And this point of care centers which you are trying to initiate is definitely going to enable such attempts from the surgeons, because ultimately the use of this technology is going to be for reducing the surgical times as well as to have a better patient outcome, and then having a very good understanding of the disease as well as very good understanding of the anatomy and the physiology. Now these things are all possible by using this technology, using the CT and MR scans, which can be then further played upon by the various softwares which are available in the market. So to take it further, as far as we are concerned at Orthotech India, we want to create a complete ecosystem. So as Dr. Girdhar Gyani was saying, that various respondents who are there into this particular ecosystem should come forward, and we look forward to participate in Jaipur, because that's where we would be able to tell you about the 3 suite that we are planning. It's a complete ecosystem where all the doctors, hospitals can send us their challenges. They can do the segmentation at their own point of care labs, but further requirement for any form of planning, preoperative planning, any form of instrumentation or jigs, or any implantable device which they require to be manufactured, everything is now going to be possible very much in India and very much in the Gujarat, Valsad area. So that's where, we want to complete the entire ecosystem, complete everything in such a manner that there are solutions which are available to every surgeons in different fields, especially dental, orthopedics, and neurology. Shibu.
Right, doctor. I mean, I'm seeing the passion and the drive that has been taken from Orthotech India, and I was a part of the journey from where we started in terms of introducing the technology to Mr. Sushant and also Dr. Yu, and I know that the way it is been able to transcend the larger intent in terms of the way it is shaping up. So all the very best to you, doctor, and also Mr. Sushant for initiating this, because I'm sure it is not confined to only orthopedics. It's going to be beyond that, because there's a lot of thirst to learn more is what I've learned from, and that's how the techno and that's how the course is set in terms of learning and growing, and all the very best, and it's always a pleasure and a privilege to be associated with Orthotech India, because you started from scratch, and now you've been in the modular space for many years, almost 30 years, but to have realized the importance of 3D technology and seeing that how it can benefit the doctors, because here it is a direct interaction with the doctors, getting them trained. And rightly so, doctor, as you rightly said, this initiative with the 3D Graphy Labs will also be conducting these training programs with each of these hospitals. As Dr. Girdhar Gyani sir also mentioned, training and education is also a very active requirement for us, which is an ongoing process. And then subsequently to then offer the right solution to the end user is something that we will also be doing on an ongoing basis with multiple webinars and initiatives and events that we will conduct in the year 2023. I'm sure it will keep us busy, and I'm sure it will also help us to get inputs from the end doctors in terms of what is the final need for them to make things more simplified in terms of various medical specialization. Thank you so much, doctor, for your time and your presence,
Thank you, Dr.
and also for your active participation as franchisee service center with us. Thank you so much. And now I have to introduce you to Dr. Claudio, who's also been an active respondent creating these solutions, in terms of materials. And so happy to know that you've also got your, grant, Dr. Claudio, with your product, which is again very unique and a very unique product to offer. So hospitals, I'm sure, will be a beneficiary, and hospitals will definitely benefit in terms of the solution, because we are not looking at only medical appliances as in confined to body anatomy. We are also looking at various devices that can be also used in the hospital per se. So the the scope is also more when it comes to ensuring that, how you can keep yourself clean and maintain yourself in terms of the, maintaining your hygiene, ensuring that, the material can take the call in terms of a key part. So your thoughts on this, Doctor, in terms of your participation and your partnership. We'll be missing you though personally in Jaipur, but I'm sure
Yeah.
we will represent and we will also share your products and solutions there. Yeah, please, your thoughts.
Thank you so much for having me this day. These initiatives are very, very beautiful and a huge initiative that you are coordinate, Dr. Shivu, in your country. On the other hand, I'm thinking the best way to adopt this technology is to start to use key opinion leaders and doctors, because doctors trust in doctors, and we are using this way here in South America, in my country. On the other hand, we would like to, in a near future, maybe travel to this event, and why not started to increase our presence as a company with a new material, with new implantable materials, and maybe with a partnership with a key respondent in your country, in India, and why not manufacture our materials over there. So thank you so much.
Yeah, so I'm sure that's the larger intent to look at in terms of ensuring that, how cost can be also reduced and it can be more accessible for having a manufacturing unit in the country. Yes, so we will definitely work towards it in terms of identifying some of the respondents, Doctor. And we will go step by step. That's the clear intention. But yeah, what is important is that now that we have a conscious effort that needs to be made in terms of the support that we are getting from some of the leading institutions, I think that will also help us to get there eventually as we progress, and we'll definitely see an opportunity working together. Thank you so much, Doctor. And last but not the least is Mr. Sarup Chand. He has been a very passionate person, and now with his new affiliations in various new solutions and with software solutions that he's also getting into, I'm sure there is much to offer. So, Mr. Sarupji, I mean, your thoughts and also your team is going to be there in the event, I'm sure, and your participation for a long haul going forward.
Thank you very much. I think it's a very good initiative, and I think it's a win-win for the technology partner, for the hospital, and I think above all for the patient, who will be able to get the benefit from this close working of the technology partners and the medical fraternity. So I wish you very good luck in this sphere. We would always be there. I have two questions from Dr. Claudio, if it's okay with you.
Yeah, please, sir. Please.
Dr. Claudio, in this, when you say that this is something which is able to take care of the bacterial repellents, can it also, how long a fixture made with this can last in terms of bacterial repellent characteristics?
Duration, we developed a test in the US. The name is aging test. We are able to say with total confidence at least the duration of this material is 1 year with all the capabilities to kill germs. 1 year, but because there are no tests more than 1 year. But empirically, we know the performance is more than 1 year. But by test, we are able to say our material works at least 1 year.
Perfect. Thank you.
Thank you so much, gentlemen, and thanks for your time, gentlemen. Also being a weekend, that needs a lot of commitment to come together and be a part of this. Thank you so much, Dr. Vikasji, for your time.
Thank you so
Also,
much.
Sarup Chandji for your time, and also Dr. Claudio for being there, and also the other key respondents, Dr. Kareem and Dr. Girdhar Gyani, and many others who could join. And also, I'm so happy to know that we also have some good number of hospitals also registered. So, and I'm sure this was just a pre-event activity for us to then build on to the HPI event in Jaipur. And I'm looking forward to all of you to be there, Doctor, because you're there, you said, and Mr. Surupji, you're also there. So we will have a good meet there, and I'm sure we will set the pathway going forward as we progress. Thank you so much.
Thank you.
Thank you.